Hi, and welcome back to our series of short videos highlighting our 2025 URTeC papers. My name is Bob Aylesworth, and I'm the Business Development Manager here at RevoChem. In this video, I will be discussing a really exciting project we did in the Vaca Muerta play with Vista Energy in Argentina. The title of this paper is Optimizing Field Development for the Vaca Muerta play using Oil and Water Geochemical Fingerprint Technology. In this project, we took a look at one-layer versus two-layer development, various spacing and staggering geometries, and how they impact production and well communication. We also took a look at the produced water to help monitor the cleanup process and determine if the wells were draining from similar or different water zones. In study area 1, we examined single-layer development with variations in spacing geometry. Production allocation results showed that wells landed in Section A drained primarily from Section A, with very little contribution from the shallower Section C, despite models and other data indicating SRV growth through the B and into the C. Production allocation results from that single layer development combined with estimated hydrocarbon pore volumes indicate that in order to better drain the C and upper B intervals, an additional landing zone is likely needed. Similarity index and production data of Section A wells suggests that higher SI indicates more lateral DRV overlap and can help indicate when wells are spaced too closely. In this case, it doesn't appear that they were. In study area 2, we compare two-layer development to that previous one-layer development and also look at changes in spacing and staggering geometries. We observed that the two-layer development in Section A and Section C significantly improve the resource utilization and provide better drainage from the Section C and even the Section D above. The wider vertical spacing may have allowed Section A landed wells to create a slightly larger vertical drainage network, which resulted in better reservoir utilization when developed with those shallower landed C wells above. When comparing the similarity index values, the wider spaced pad F wells have lower similarity indices than compared with the pad G wells, which were a little tighter, and that indicates that the slightly closer spacing from those G wells creates more lateral DRV overlap and more communication, especially in the Section A. And finally, the water analysis that we did showed that the Vaca Muerta is quite unique when it comes to produced water, with wells flowing back a significant amount of the frac water early in production, and this cleanup process can last more than 7 months, indicating that the reservoir doesn't imbibe the fresh water as quickly as other formations, which is possibly related to higher irreducible water saturation and higher reservoir pressure. Ultimately, though, when the wells did clean up and produce predominantly formation water, we saw that the geochemical signatures of the water showed very clear separation between samples collected from the Section A and Section C and Section D wells, which indicates that the water drainage from these wells are coming from different sources. And so finally, I just want to thank Vista Energy, co-authors Tristan Speranza, Jorge Torres, and Ignacio Alderete. This was a fantastic paper in a really exciting formation, a really exciting play. If you have any further questions, please don't hesitate to reach out, and I encourage everyone to go download that URTeC paper. Thank you.